So, good evening to all of you, and we will start with a new topic. Write down the first topic. Write down the topic as the need of converting the need of converting a number converting a number converting a number from a one number system to another. Converting a number from a one number system to another. එක number system එකකින් තව number system එකකට numbers convert කරන්නේ මොකද කියන එක තමයි ඔය අපි කතා කරන්නේ. Right. So now write down a small sentence right below that topic. Topic එකට යටින් ලියා ගන්න sentence එකක්. All the types of input data. All the types of input data. All the types of input data those fed into the those fed those fed into the computer those fed into the computer those fed into the computer exist in binary form exist in binary form. Now we are going to discuss something about this particular sentence. So whatever we insert will be in binary form. That's what it says. What is this binary form? Let's have a look, right? Let's have a look what this binary form is. A binary form එකෙන් මොකද්ද කියලා අපි බලමු. Now we have first the different types of what? Contents or different types of data. අපි ගාව තියෙන එක එක જાතේ data. What those data are going to be? One is going to be text data. Textual data. So then you can say image data. Image data. Audio data. And video. Those are the different types of data that we can see in a computer environment. We can see these are the data that we feed into the computer. How do we feed the textual data into the computer? How do you feed text data? Yes, using what device do you feed the text data into the computer? The normal usual method is using a what?
Keyboard.
Keyboard. Using a keyboard. You can give data into the computer using a keyboard. Right? Right. Now, if you take images, so don't draw this now. මම කියන අදින්න යන්න එපා. So because I have to sometimes modify them. I can modify it easily, but you can't because I'm using a whiteboard, you are using the pen. So until I say don't draw anything, image and audio. Text is inserted using the keyboard. Audio is inserted using what? What do you use to insert audio? Amindi? Yes, what is the technique or device that you use to insert voice into the computer? So all these are going to be input devices. What is the technique? Input devices. Right now, tell me, Amindi, can you tell me what is the technique that we use to insert audio or sound into the computer? Damiru? No one speaks. You have to tell me, right? Now, okay, I will proceed. If you were in a physical class, I will get the answer somehow, but now since you are not physically accessible, I can't force you, right? Microphone is the device that we use to insert sounds into the computer. When I speak, you can hear my sound. So this computer has a mic or a microphone. So that microphone is going to capture the voice of what I speak and it will be sent to you. Then we have image and video. Now, can you tell me how do you capture image and video? What is the input device that we can use? Can anyone tell me? Raniji?
Yes, sir.
So what is the device that you use to capture video or images?
Camera.
Yes, you can use the camera. You can say cam. Once you insert them, for example, now let's say you insert the text like you type something like hello, or let's say these letters you can type hello, or you may type just a single letter like letter A. You'll make it more simple. Let's say you type letter A from the keyboard. So you type A here. Audio I can't show you. I can just show you it has some kind of a wave that goes on. Images you can see a tree, a person. So this is an image or a picture. Videos also I can't show you properly. So these are the different types of data. So this is a text data, this is an audio, this is an image, this is video. So this data, once you insert through these devices, it will in turn go into the central processing or the system unit. Right? So this is the system unit. It will go into the system unit. And inside this system unit, it will be represented in the binary form. Now, Damiru, can you, okay, Amindi, Damiru came a bit late, so I don't know whether he wrote the note. So keep some space, about 3 or 4 lines to write whatever you missed. So මොනහරි මිස් වෙච්ච දේක් තියෙනවා ඒක ලියා ගන්න page 3-4ක් තියන්න. So Amin, can you uh, tell me what you wrote as the line after the topic? Topic එකට යටින් ලියාගත්ත ඒ line එක කියවන්න බලන්න එකපාරට. To hear to all of us. ඔක්කොටම හින්න.
No, I didn't write it complete.
Or didn't complete it? Okay.
Yes.
So what I told was, okay, the different types of data are represented in binary form, right? So may data, these are the different types of data. So we can write it as, these are the different types of data are represented inside the computer. This is our computer. Inside the computer in binary form. So whatever you enter here, letter A, or whatever you enter as image, everything should be in binary form. What is this binary form? So this particular letter will be represented as the binary number inside this like this. So it is going to be a series of zeros and ones. And also this audio will also be represented inside the computer as series of zeros and ones. And this image will also be represented inside the computer as a series of zeros and ones. And this video also will be represented inside the computer as a series of zeros and ones. And we call this as the binary representation of data. And these zeros and ones are binary representation. Those are the binary representation of data. Okay. So we have system unit and we have this data which is represented inside the system unit in binary form. Up to this, did you understand? Is it clear?
Yes.
Good. Now, others?
Yes, sir.
Okay. I hope all of you understood it. So whatever you insert from this will be converted to this signal and will be stored inside. So this particular data will be going from the keyboard and stored here. May signal so you don't want to worry about how this is stored inside, how this is actually the zeros and ones are stored inside the computer. That is actually in the next lesson. So we will only just keep in mind that whatever is entered as letter A will be converted to something like this. අපි මේ enter කරන letter A එක අන්තිමට convert කරන මෙන්න මෙහෙම බිංදුවේ සහ එකේ ඒවට එකකට ගොඩකට. අන්න ඒක තමයි අපි ඔළුවට දානවා. So we have to keep that in mind. So that is called the binary representation or binary form. අපි කියනතර මේ කියන්නේ මේ data වල මොකක්ද binary representation. And inside the computer, these are held in circuits. We are hearing circuits. So these zeros are represented as the places where there is no voltage. Ones are represented as where there are some certain charges. Charge එක තියෙන නැති විදිය තමයි තියාගන්න. So we will not discuss about that. That is too complex at this level. So since you are grade 8 students, we will not go to that extent. So we will not discuss that. How this is going to be maintained inside the computer. මේ කොහොමද computer ඇතුලේ maintain තියන් ඉන්නේ කියන එක අපි discuss කරන්නේ. So soon after this is going to be into the computer, it will be in this form somehow inside the computer, and we are not going to discuss how it is maintained inside the computer. Instead, we will discuss how now after you insert it, what will happen? After you insert letter A, it will go to the computer and it will be in this form. And also afterwards, it will be also displayed in the computer's monitor, which is an output device. and this is the monitor. So on the monitor, it will be displayed as letter A. And also, if you want the particular picture to be displayed, it will also be just sent to this through the wire, and the monitor will display the photo also, the tree and the person, the same photo here. Right? So now you can see the conversion is happening back and forth. I mean, first it will be converted to the binary, and then it will be again reconverted or converted back to whatever we can interpret or we can see. දැන් ඉස්සෙල්ලාම මේ අහුර convert වෙනවා binary වලට මේ විදිහට binary representation වලින් හැරවිලා ඊට පස්සේ ආපහු ඒක අනිත් පැත්තට ආය අපිට පේන form එකකට හැදෙනවා monitor එකේ. ඒ monitor එකේ මොකද වෙන්නේ? අපිට ආපහු පෙන්නනවා. So monitor, printer, projector, ඔය ඔක්කොම all these are output devices. So this representation we are going to study further. Okay, now under or below that particular line that you wrote, write or take this down and then under. if you finish, please let me know. ඉවර වුණා ගමන් මට කියන්න ඕනේ. ඔක හරිද? Finished. ඉවරද? තව වෙලාව ඕනද කාටද?
ඉවරයි සර්.
අමින්දි බලලා ඉවරද නම් කියන්නේ. So
done sir.
හරි. Now write down I mean erase this stop area and put a now in the corner of the ruler අගින් මෙහෙම bullet point එකක් දාන කළු පාට මෙහෙම තිතක් දාලා ලියන්න පළවෙනි point එක. So we are going to write several points like this in each rule. අල්ලා rule ටික ඔන්න bullet points ටිකක් දාගෙන ලියන්න යන්නේ. පළවෙනි එක දාන්න the first one. Write down the first one. Different types of data right in the first point, right? Different types of data are fed into the computer, are fed into the computer, are fed into the computer using using input devices, using input devices are fed into the computer using input devices. Number two, not number two actually, second bullet. දෙවනියට යටින් තව කළු පාට මේකත් දාලා දෙවනි බුලට් පොයින්ට් එක ලියන්න. The input devices, the input devices converts converts this data converts this data into binary form, converts this data into binary form and sends to the system unit. And sends to the system unit. And sends to the system unit. Third bullet point, තුන්වෙනි එක. Third one, write down. The system unit, the system unit, the system unit maintains this data, maintains this data the system unit maintains this data in binary form. In binary form. The system unit maintains this data in binary form. The system unit maintains this data in binary form. Number 4. හතරවෙනි. So, fourth bullet point. The binary data inside system unit, the binary data inside system unit the binary data inside system unit can be presented can be presented through can be presented through PHROUGH output devices can be presented through output devices such as monitor output devices such as monitor. Right, I think you can understand this particular scenario. You can make it and you should be able to understand whatever is explained here. So when you read those bullet points, you can understand. Now we are going to study about how this data is represented in this form. මේ data කොහොමද මේ විදිහට හැරෙන්නේ කියන එක ඉගෙන ගන්න යන්න. So for example, letter A, you have a certain code like this that represents letter A inside system unit. Letter A කියන්නේ A අකුර ගත්තොත් A අකුර මේක ඇතුළේ represent කරන්න මේ එක මෙහෙම මේ binary representation එකකට වෙනවා තියෙනවා. B අකුරට තව එකක් තියෙනවා. So if you take letter B, it has another set of ones and zeros like this, which is a binary number. If you take a sound audio, again it has again a series of binary numbers. But since this data is really complex, if you take textual data, if you take images, if you take numbers, everything are very complex. Because of that, we will not discuss this representation with these data. Instead, we will see how the numbers, because to understand this concept, it is easy to do it using the numbers. Right? So අපිට මේවා නැතුව දෙලින්ම number එකක් කොහොමද මේ represent වෙන්නේ කියන එක තමයි අපිට බලන්න එක lazy. So now write down the topic. The representation of write the topic. This is a topic, right? The representation of the representation of the representation of decimal numbers the representation of decimal numbers inside the computer. So numbers are another type of data, which I did not write before. So deliberately I did not write it. So if you take number 23 or something, 95, all these are numbers. So you enter these numbers using the keyboard. Once you enter these numbers using the keyboard, again, the signal is going to be sent to the central processing unit. And now we are going to find out how this particular number is going to be represented inside this. For example, now if I just indicate it properly, we have to find out how this number is going to be represented inside this, and how this particular number is going to be represented inside this. Okay, so that's our objective. Draw this diagram. Finish drawing.
Done, sir.
Okay.
Done, sir.
Right. Now we are going to discuss about next thing. So I will show you a smaller diagram. So I sent you this PDF of the text PDF files for your reference. You can see uh, what happens now. You can see numbers 1, 2, 3. Number 1, user cross press the number 9 on the keyboard. Then processor identifies the number as a bit pattern of this. So you can see now once you press this uh, from the keyboard, the signal goes inside the system unit. The system unit has the processor which can understand this as number 9, and later it also can be sent to the monitor and interpreted as or shown as number 9 later. Then also you can see the steps that happen. So whatever I actually demonstrated here is also there with more details. So make it මම අර පෙන්නපු එක තව විස්තර සහිතව ඔයාලට බලා ගන්න පුළුවන් මේක. Okay. Now we come to discuss about the conversion. Right. So we'll discuss how we can now anyway to understand how these decimal numbers are represented inside binary numbers. We have to do the conversion from decimal to binary. Right. So write down the topic as converting decimal number to binary. Converting a decimal number to binary. Converting a decimal number to binary. Converting a decimal number to binary. So this is the decimal number. This number has to be converted to a binary. So then you can get how the number is represented inside the system or the computer. We did not discuss about other data types because I told they are too complex. But numbers, it is sensible for us. We can easily understand because we have done mathematics for your previous and even for this term you have doing mathematics. So you know how you can divide things, how you can multiply things. So we can now take this number which is in decimal and do some operations or mathematical operations with it and also convert it to a binary form. So then always remember that whatever we have in decimal, once you convert it to the binary version of it or the base 10 number to base 2, if you convert the base 10 number to base 2, then it is going to be the binary representation of this number inside the computer. Okay, so I'm going to have I'm going to convert this now and show you how to convert from a decimal to binary. Right, now let's see how to do that. So don't write this, I will first instruct you the way to do it. So now, normally when you are, so you have to keep on dividing from 2 to convert the number from decimal to binary. So for example, let's say number 6. When you are normally dividing a number, you just put these 2 lines like this. And you divide. So we have to always, if you are converting a decimal number to a binary, you have to divide it by 2. And you have divided it by 2. But in this situation, we are not going to use this particular line. Right? It is a bit different. We'll be using it like this. So we'll put that line below like this. Okay, I hope you can see that. So 6 is the decimal number, which is of base 10. 2 is the one that we are going to divide. So we are going to keep on dividing this number. Right. So now we can see. First, we will divide this 6 from 2. Once you divide, you have to identify what is the value after division and what is the value that we are going to get as our remainder. දැන් අපි දැනගන්න ඕනේ මේක බෙදුවට පස්සේ එන ගානයි ඉතුරු ගාන. ඒතකොට ඉස්සරහින් මේක බෙදනවා. So we'll divide it. So once you divide it, you can get 3 here and there is no remaining amount. You know that 6 is completely divisible by 2. But even if it is divisible by 2, so once you divide by 2, so you can get 3. There is nothing remaining. But you should not ignore any, the amount, the remainder. So you have to put that there is nothing to be remain. There is no remainder. So අපි මේකෙදි සාමාන්‍යයෙන් 6 දෙකෙන් බෙදුවට පස්සේ අපිට හම්බෙන්නේ 3. එතකොට ඉතුරු ගානකුත් නැහැ. ඉතිරි වෙන්නේ නැහැ කීයකට 6 දෙකෙන් බෙදුවට පස්සේ. ඉතින් ඉතුරු නැහැ කියලා අපි ඒක ඉග්නෝර් කරලා දාන්න බෑ. ඉතුරු නැහැ කියලා ඉතුරු බිඳුවයි කියලා හරි දානවා. You have to put that. There is no remainder. You have to put 0 right next to this. Then until you get 1, you have to keep on dividing. Then again you divide this by 2. Then what do you get? So inside we have 1, 2. කියන්නේ 3 ඇතුලේ 1 2ක් තියෙනවා. එහෙම නැත්නම් හරියට 3 දෙකෙන් බෙදුවාට පස්සේ අපිට එන්නේ ඇත්තම කිව්වොත් 1.5. Calcium pine, but you should not do it like that. එහෙම කරන්නේ. We should not use decimal numbers for that. We have to first divide it again. Then you get 1 inside this. And there is a 1 remainder. They can බෙදුවම එකයි ඉතුරුත් එකක් තියෙනවා. So you can see first we divide 6 by 2. So you get 3, no remainder. Then again we divide it by 3. So you get 1 and there's a 1 remainder. So now we have to start reading from here in this direction. Once you get 1 here. And then the 1 කෙනෙක් ආවොත් මෙතනින් එහාට අපි මෙහෙම කියවන්න ඕනේ. So make here first you have to get this 1, then this 1, and this 0, and this is going to be the decimal conversion, the binary conversion of number 6. So this is of 10 base 10, this is of base 2. So this is converted to this. And this particular value, these are the values that you are getting. Okay. Amindi, is that clear for you?
Yes, sir.
Right. So can you take this down? Then we will do some more exercises on that.
Done, sir.
Right. Now I'm going to give you the chance to convert a number by yourself, then make Paramahan. Now we did the one, so you have to convert number 9 of base 10 to its binary version. Do it now. Number 9. Can you see this? Board. Okay, now it's clear.
Done, sir.
Okay. So can you tell me the answer now? You can tell me in ones and zeros. How does it start? Ones and zeros in Indian one. Indian one. I mean, you can tell.
So still I'm doing it.
Okay. Pranidhi, is that you who told that you finished? Pranidhi, ඉවරයි කියලා කිව්වේ?
No, sir.
No, okay.
But I'm done, sir.
Okay. Aminti, have you finished?
No, sir.
Right. So we'll do it now because we have to do certain more stuff. So next one, I expect Aminti to complete, right? So Pranidhi, can you tell me the answer?
One zero zero one.
1, 0, 0, 1. All right. So we have to indicate it is to the power 2 or base 2. Right? We have to indicate that it is from base 2. So now we will divide it. So normally we don't put it as 10 here because we know that it is from base 10. So we first we divide it by 2. Number 9 is there. Inside number 9, how many 2's are there? So when you divide number 9 by 2, it is going to be 4.5 if you divide it into decimal points. But anyway, if you take whole components of 2, they are going to be 4. So මේ දෙක use කරලා අපි 9 බෙදුවා. දෙකේව 4ක් තියෙන 9 ඇතුළේ. ඒ කියන්නේ 8 තමයි අපිට හම් වෙන අඩුම සංඛ්‍යාව මේකට පස්සේ. So we have to put 4 inside this. And we have 1 remainder. Hope you understood it, right? So අපිට 9 දෙකෙන් බෙදුවට පස්සේ අපිට 4ක් එනවා. ඉතුරු එකක් තියෙනවා. Then again we divide it by 2. So you get 2 and 4 means it is completely divisible by 2. So therefore there is no remainder. Again we take and 2 here. So we have 1 and there is no remainder. So we have to go like this. Reading this. So if we take this 1, this 0 here, and this one. So මෙතනින් පටන් ගන්නවා. And this 0 is this. Right. Next one, I'm going to definitely ask Aminji to complete, right? Because I want your result, so I want to see how you can do it by yourself. ඉතින් මේක ගැන ඊළඟට අනේ කරන්න ඕනේ.
Okay, sir.
Okay. Let's do a number like now do this a bit larger one, 37. Convert this to binary. One of these again. Now do it alone. Number 37, can you convert it to binary? Because you will get questions like this in the examination. Right.
Done, sir.
Done. So can you tell me the number sequence starting from?
One,
Yes, sir.
one,
One,
zero, zero,
zero.
zero,
Tell slowly. Tell slowly. One, then
zero,
zero.
zero,
Yes.
one,
Hmm,
zero, one.
one. This is the. So is that correct? But I don't make it. Okay.
Yes, sir.
All right. We'll see whether it's the answer. So we'll keep on dividing it by two. So we get here 1 and 8 and 1 remainder. Again we divide, we get 9, no remainders. Again we divide, we get 4, 1 remainder. Again we divide, we get 2, no remainders. Again we divide, we get 1, no remainder. So let's leave this so we can see 1, 0, 0, 1, 0, 1. So very good. So we have done it. Okay, good. So we'll now. So Pranidhi, you are also very good because you did it in the first one, and Amindi, I just wanted to check whether she can do it. So she also can manage it. So now we will get some more questions on this. So do this as your homework. I will give you some more questions on conversion of numbers. So convert these numbers. So I will do some more big numbers, but I'm looking for them. 137, 137, 649, 982, and 1768. These are your homework. Use a pencil and first do them, right? Homework, right? Take a pen or just take a rough sheet. පටු එක කරලා බලලා පස්සේ හරියටම උත්තරේ ෂුවර් නම් පොතේ ලියා ගන්න. So after you do it in a rough sheet, please copy it down into the book. So don't take a pen and write on the book itself at once, just because sometimes you might, because when you take a longer number, you will need to write it a long length. මේවා හැකට ගොඩාක් දිගට ලියන්න වෙනවා. In the try this out. That's for your further practicing. When you put a practice make it right. Next. Now after you do that, we have to again do another thing. Right. So once you convert it to decimal, sorry, binary, again, if you want to convert it back to decimal, how to do that? I think I explained you how to do that in a one lesson, but again, we have to do it. So we'll take, okay, write this down. This is what you have to do as your home. ලියාගන්න homework කියලා කට්ටියන් ලියාගන්න මේ ටික කරන්න ඕනේ. ඉත ලියන්න එපා, you can do it in a rough sheet.
Done.
Okay. So what was the second number I gave? 37. Is that 37 that I gave you? Yes, 37, right? Okay. And what was the answer we got? 1, 0, 0, 1, 0, 1. Is this the answer?
Yes, sir.
Now, this is in base 2. Now, we should be able to also get the decimal number out of this. So, we have to convert this back to decimal. To do that, you should know the different values that are held in each position. So there are, at this moment, we have 6 positions. So we should know the positional values of this. අපි දැනගන්න ඕනේ මේවා ස්ථානීය අගයන්. අපි කියන ස්ථානීය අගයන් නැත්නම් positional values කියලා. Positional values, right? Or place values. When you take this, I will expand it a bit. I'll put my pencil here now, so it will be much more easier. 1, 0, 0, 1, 0, 1. The positional value of this is going to be 2 to the power 0. Position value of this is 2 to the power 1. This is 2 to the power 2. 2 to the power 3. 2 to the power 4. 2 to the power 5. These are called positional values. So can you remember previously we just found out how a number is made of. If you take a decimal number, let's say 984 to the base 10, we just checked out how this number is created. If it is in decimal form or decimal or base 10. So this is having 10 to the power 0. This is having the place 10 to the power 1. This is 10 to the power 2. So what to get this number, what we did was multiplying this positional value by 10 to the power 0 into 4, 10 to the power 1 into 8, plus 10 to the power 2 into 9. So if you can go to the previous notes, this has been done. So when you take this 10 to the power 1 is always is going to be 1 into 4 plus 10 to the power 1 is 10 into 8 plus 10 to the power 9 is, so 10 to the power 2 is 100 into 9. So it's going to be 900 plus 80 plus 4 is going to be 984. That is how a decimal number is created. Similarly, you can see to understand how this binary number is converted back to decimal, we have to discuss about the same thing in the same structure. The may විදිහටම අපි මේකත් බලන්න. Okay, so I just revise this for you to understand. So now we come to discuss about this in detail. So you can see now 10 to the power 0. Always remember 2 to the power 0 is going to be taking value 1, 2 to the power 1 is going to be taking value 2, 2 to the power 2 is going to be taking value 3, so value 4, 2 to the power 3 is going to be taking value 8, 2 to the power 4 is going to be taking value 16, 2 to the power 6 is going to be taking value 72. So you have to remember this particular thing. So how do you create this one? It is actually, so this one is 2 and into, so it is only 2. This is going to be 2 into 2. This is going to be 2 into 2 into 2. This is going to be 2 into 2 into 2 into 2. This is 5 times 2. 2 to the power 5. Sorry, this one should be 5. Like this it goes on. So this is a certain table that you might have to refer when you simplify that. Right. Okay, so I hope that you didn't write anything here. So first, write this, just put a topic, converting binary numbers to, sorry, converting binary numbers to this, converting binary numbers to decimal numbers. So I don't think you wrote the topic, so write down converting binary numbers to decimal numbers. That's the topic. Okay, then write down uh, the powers of two. Write down subtopic, the powers of two. The powers of two. Powers of two, and write this. Powers of two. දෙකේ බල powers of two. කියලා මෙන්න පොඩ්ඩක් ලියාගන්න.
Done.
Right. Pranidhi, finished?
Done, sir.
So you have that table with you now. So we are going to now find out how to evaluate this. So we have now 6 digits. We call them binary digits. Binary digits here. So now if you take the first position here, you have to do something like this. You have to multiply 2 to the power 0 from this number 1 when you're converting it to binary. Sorry, decimal. Then plus, you have 0 here, multiply it from the place value, which is 1. Again, plus, place value is 1 into 2 to the power 2. Place value 0 into 2 to the power 3. Plus 0 into 2 to the power 4 plus 1 into 2 to the power 5. This has to be simplified. I hope you can see now this board, right? Now we are going to further simplify this. You can see 2 to the power 0, this is 1. This is going to be 2 to the power 0 is always 1. So look at that table into 1 plus this is going to be if something is multiplied by 0, that will be always 0. So don't try to find out what is 2 to the power 1 means. It's 2, I know that, but still you multiply it by 0, so it is going to be 0. අපි මේ බිඳුවෙන් ඕනම වැඩි කරොත් බිඳුවනේ. එකකින් තමයි මේ 2 to the power 1 කියන මොකක්ද කියලා බලන්න යන්න එපා. අපි වෙලාව ඉතුරු කරගන්න. බිඳුවේ වැඩි කරා බිඳුව වෙනවා කියන කෙලින් බිඳුව දාන්න. Make 2 to the power 2 is 4, but it is 1, so therefore multiply. This is 0. 0 means 0 plus this is also 0 plus 2 to the power 5 is 32 multiplied by 1. So I got it from that table, right? So ultimately you will get 32. 0 means we will ignore it. So you will put it down. 0 plus 4 plus 0 plus 1. So 32 plus 4 is 36. 36 plus 1 is 37. And now that was the value that we converted before. Only then 37 කියන එක එනවා. So we get 37 back. Okay, take this down also. So you should be able to do these conversions back and forth. මේවා එහාට මෙහාට කරන්න පුළුවන් වෙනවා. I mean, have you finished?
Yes, sir.
So you have to. So next day we will do more exercises on this other conversion. Do the homework. Right? So do the homework, and we next day we will do some more conversions on this. Make conversion එක තව අපි කරන්න ඕනේ. Homework කරන්න මේක කරගෙන ඉන්න. Okay, so next day we'll meet with the last part of the lesson. Hopefully, let's try to finish that first lesson next day and proceed to the new lesson on the coming week. Right. So thank you both of you for being in the lesson and good night. We'll stop now.